Hi, this is Peter with CalcBook, and today we're going to be looking at a C-shaped weld, continuing our weld design series. So a C-shaped weld might be just a channel welded to something, or you have a plate that's got three sides. We'll be using the AISC Specification Chapter J. We'll be using the Blodgett method, right, which treats the weld as a line with no throat. And we'll be able to evaluate 6 degrees of freedom with this type of weld. So we have Fx and Fy, which are the in-plane forces, Fz, which is coming out of the page, and then we have our moments about X and Y, and our torsion, Mz. So we'll take a look at our problem statement, right? We've got a steel bracket that is welded to a plate with 3 sides there. We're using E70 electrodes. We have an applied loading of 60 kips, right, at the end there in that eye hole there, that eyelet. And we want to determine the minimum fillet weld to resist the applied loading using LRFD. So before we get into CalcBook, we need to do a little bit of math here to get our loading that we can enter directly into CalcBook. So the first thing, right, we're just going to take our straight in-plane Y force. That's easy. It's just 60 kips. But for MZ, right, we need to calculate the moment about the centroid of that weld shape so that we can input our moment. So the first thing we need to do is calculate that X value, right? And CalcBook actually does this for you, so you can just use that and then multiply your force by that number. By the eccentricity. So we get our X value there, the distance to the centroid, and then we add our 8 inches extension there off the end of the plate, and then we take our 16 inches of the weld minus the centroid distance, and that gets us a total eccentricity of 17.6 inches. Then we can multiply that by our 60 kips, and then we can convert it, and we get 88 kip foot. So that is going to be the loads that we enter into CalcBook: 60 kips Fy, and then 88 kip feet for Mz. So let's go ahead and open up CalcBook, and we'll get started on the design. All right, we got CalcBook open now, so we're going to click into our steel design module, and then into our connection design. We'll toggle over to welded, and then we'll scroll down until we get to our C-shaped weld and click continue and get that loaded up. Okay, so we go ahead and enter in the width of our weld. So that's going to be 16 inches. The height of our weld, which is going to be 8 inches. The weld leg size we'll leave at 1/4 inch for now. If we need to come back and update that, we can. We'll go over to our demand tab. For load combinations, right, we are not going to use any load combinations. We have already have our ultimate force on this connection. So our force in the X direction is going to be 0. Our force in the Y direction is going to be 60 kips. No force in the Z, and then the only other moment we have is about the Z axis, right, the torsion, and that's going to be 88 kip feet. And so we already are pretty high here on our 1.45 DC ratio, but let's look at the calculation first, and then we can come back and make some adjustments. So the one thing we want to look at is we can go to the demand on the weld here. And before I mentioned that CalcBook does calculate that distance, so that dx here, right, that calculates that 6.4 inches. So you can use CalcBook first to find out that distance, and then calculate what your moment is, and then you can enter that in. So that it does the math for you there. So we calculate the rest of our section properties for the weld. So our length, our section modulus, and then our torsional constants. And then we do the weld stress due to each component, right? So in this case, we just have 2. We have weld due to the force in the Y direction, so we just have 60 kips over the total length of the weld, which gets us 1.5 kips per inch. And then we have a component due to Mz, and we have 2 different components here, right? One for the horizontal legs of the channel, or the C shape, and then one for the vertical component. So it's just taking the moment, dividing by the torsional constant, and then including either the distance to the horizontal legs or to the vertical leg from that centroid. So calculates both the horizontal and the vertical leg components there. And then from there, we can go ahead and calculate our total weld resultant stress, right, using our square root sum of the squares, and we get a total shear per unit length of weld of 8.07 kips per inch. So on the capacity side, right, we already saw that we are over capacity. Well, let's take a quick look here. So we have the area of our weld. We calculate the nominal stress, our directional strength factor, which we take as 1 for this type of connection. And then we get our design weld shear strength of 5.57 kips per inch. So we're a little bit short there. So we can just go back to our capacity. We can go up to 5/16. Not quite there yet, 1.16, so maybe a 3/8 weld will work. and there we go. We're at 0.97, so we are within the demand capacity ratio of 1. So that is a C-shaped weld design in CalcBook. We hope you enjoyed the video. If you have suggestions for other calculations or other videos you want to see, please let us know in the comments below, and we'll see you next time.